The cosine rule. Learning intention. To apply the cosine rule to calculate missing sides and angles in any triangle. Success criteria. I can recognize when to use the cosine rule when I know two sides and the included angle, or all three sides. I can use the formula a squared equals b squared plus c squared minus 2bc cos a to find a missing side. I can rearrange the formula to find a missing angle. I can calculate accurately and round answers to the required degree of accuracy. In each of the triangles shown below, we are given three pieces of information. In triangle A, we are given two sides and the included angle, i.e. the angle between them. So we can see we have the sides 7 units, 8 units, and the angle 48 degrees between them. In triangle B, we're given the lengths of the three sides. We're given 4 units, 6 units, and 5 units. In neither of these triangles can the sine rule be used to find the remaining sides and angles. So you have to use the cosine rule. To solve these triangles, we can use another rule called the cosine rule, which is given below. So for any triangle ABC, a squared is equal to b squared plus c squared minus 2bc cos a. And the triangle is labelled in the same way as it is for the sine rule. So angle A is opposite side A, angle B is opposite side B, and angle C is opposite side C. This is page 16 of your formula book, the trigonometry page, and you can see the cosine rule is circled here in red. So a reminder that the cosine rule is used to find an angle when three sides are given. So to find an angle when three sides are given, or it's used to find the third side when two sides and the included angle are given. So two sides and the included angle are given and you're asked to find a third side. Example 1. In the given triangle, AB is equal to 6 units. So this side here, AB is equal to 6 units. AC is equal to 8 units. So AC is equal to 8 units. And the angle BAC is equal to 48 degrees. So BAC is equal to 48 degrees. Find BC, so the length of the side here, BC, correct to the nearest integer. So an integer is a positive or negative whole number. So correct to the nearest whole number. The cosine rule can be used when two sides and an included angle are given. So we've been given two sides and an included angle, so we can use the cosine rule. But if you forget this, you can try the sine rule, and if the sine rule doesn't work, then try the cosine rule. The cosine rule is a squared equals b squared plus c squared minus 2bc cos a. So our triangle was already labelled with angle A, B and C, so then we label the opposite sides as the lowercase letters. So if this is angle A, this is lowercase a. If this is angle B, this is lowercase b. If this is angle C, this is lowercase c. So a squared, a is what we're looking for, so it stays the same. So it's just a squared. The b squared is going to be 8 squared plus c squared, so that'll be plus 6 squared, minus 2 times b. So b again is 8, so we're going to put 8 inside the brackets, times c, which is 6, so 6 goes into the brackets, and that's cos A, which is cos 48 degrees. So you can just stick it into your calculator and you'll get 35.763417. So 4 decimal places is fine. So a squared is equal to 35.7634. So a is equal to the square root of 35.7634. So a is equal to 5.9802. And rounding off to the nearest integer, the nearest whole unit. The 5 is the rounding digit, the 9 is the telling digit, the 9 tells the 5 to round up. So a is approximately equal to 6 units. So the side BC is equal to 6 units. So BC is approximately equal to 6 units. Example 2, find the angle ABC in the given triangle. So A, B, C, we're interested in this angle. So we've been given 3 sides and asked to find one of the angles. So the cosine rule can be used when 3 sides are given. So this is the cosine rule, a squared equals b squared plus c squared minus 2bc cos a. So we're going to rename the angle you're looking for as angle A so that you can sub it into the formula. Because in the cosine rule, the only capital letter is A, so cos A. So the angle that we're looking for, we're going to relabel as A. So angle B gets relabeled as angle A. So if this is angle A, then the opposite 5 is going to be lowercase a. We're going to label that as lowercase a. And if this is angle A originally, and now we have a new angle A, we'll have to relabel this angle as well. So we rename the sides to match. So if this is now capital A, angle A, capital A, the opposite side 5 gets labeled as lowercase a. This A, this capital A, has to be relabeled as B because we can't have 2 angles called angle A. So we relabel this as capital B, and then the side opposite it gets labeled as lowercase b. And then angle C can stay as it is. There's no need to change that. And then the side opposite it becomes lowercase c. So now we're ready to sub into the formula. So a squared becomes 5 squared. B squared becomes 6 squared. Plus c squared becomes plus 4 squared. Minus 2 times b. We put 6 into the brackets for b. And then we have c. So we put 4 into the brackets in place of c. And then cos a just stays as cos a because we don't know what that is. So this is what we're trying to find now. We're trying to get the cos a on its own. So 5 squared is 25. That's equal to 36. 6 squared is 36. Plus 4 squared is 16. And minus 2 times 6 times 4 is minus 48. And then we stick on the cos a. So now we're going to solve for cos a, get cos a on its own. So we bring down the 25 and the equals. And then 36 plus 16 is 52. And we bring down the minus 48 cos a. So then the 52 comes over the equal sign to become minus 52. And we bring down the minus 48 cos a. And then 25 minus 52 is minus 27. And we bring down the minus 48 cos a. And now we want to get cos a on its own. And minus 48 is stuck onto it. So we have to divide by minus 48 to get the cos a on its own. And if we divide by minus 48 on the right, we must divide by minus 48 on the left. So minus 48 divided by minus 48 is 1 because anything divided by itself is 1. So you just end up with cos a on its own. So essentially you could say they cancel each other out. And then minus 27 divided by minus 48 is positive 27 over 48 because a minus divided by minus is a plus. So we have 27 over 48 equals cos a. And I'm just going to flip them around the opposite way. So we've got cos a is equal to 27 over 48. And when we do not know the angle, we have to use the inverse. So we press shift cos and the power of minus 1 comes up. The bracket will open. You press the fraction button and put 27 over 48 and close your bracket. So just a reminder, we use the inverse when we don't know the angle. And we get 55.7711 ... I'm going to round off to 1 decimal place. They didn't specify in the question, so I'm going to choose to round it off to 1 decimal place. So the 7 is my rounding digit, and this 7 here is my telling digit, and this 7 tells the other 7 to round up. So the angle ABC, so this angle here, is approximately equal to 55.8 degrees.